Hello friends, welcome back to Tech with Viresh. So today in another edition of Spark and Scala Deep Dive in Understanding, I'm starting a new series today wherein we'll look from the hands-on perspective how to start with the Spark and Scala development. So as part of this series, in this first video, we'll look how to set up a Spark and Scala integrated development environment with Eclipse, how to get your dependencies and libraries, how to set up a project, and how to get it working on your local system so that you can build your logic, use the Spark APIs, and quickly test it on your local environment with some sample data set. So this will expedite whole of your development life cycle, and this is the usual way how the application development is done with Spark and Scala. So guys, let's start. And before I start, I would definitely like to request to all my viewers that do like, comment, share, and subscribe to the videos and to my channel. So guys, let's start. So let's quickly jump on to the Eclipse. I'm using Eclipse to start with this development life cycles. If you prefer, you can use IntelliJ as well, but more or less the project setup remains same. We are using Maven as the dependency management, and Scala obviously is our language. So let's jump on to the workspace. So this is Eclipse, added workspace. What we simply need to do is do a right click on here, click on new, go to others, and here click on Maven. So we'll create a Maven project. We'll select a Maven project and click on next. Here we'll select a create a simple project and do a next. We'll add some group ID com.viresh.say tech, and artifact ID is the name of your project primarily, or the executables that you want to create. That is the name that will be used for that. So let's name it, say, demo training. Okay, and we can give some name. Those are optional fields. You can have more elaborate descriptions, and click on finish. So it will create one Maven project, if you see here. Okay, so it has taken some default GREs and some project structure. We've got a POM file as well. This POM file carries the artifacts IDs and the group IDs that we have given, right? If you see here, I've got the group IDs, name and description, right? Let's do a right click on this and try to settle its build configurations. And before we do that, let's do a right click, go to configure, and do a add Scala nature. So let's convert it into an Scala project. And just want to tell you the Eclipse ID that I'm using is the Scala ID. So you can download the Scala ID. That's a separate one from Eclipse. It's based on Eclipse, but just for the Scala development. So the Scala libraries that we're gonna use for this particular demo project is 2.11. So we do a right click, go to build properties, and here first let's change the source name. The simple archetype has created a project with a Java. Let's change it to Scala, and we can do the same stuff for test. We don't need a test for now, so we can just remove it. Then we'll click on libraries. Here we'll remove GRE 1.5. We'll be using 1.8. GRE system libraries, click on that, choose the 1.8, and Scala libraries also we're gonna use 2.11. So click on add library, Scala libraries, and choose the latest 2.11 bundle dynamics. Click on finish, apply, close. So you got this is the structure now. We got the GRE 1.8 and we got the Scala libraries at 2.11. Perfect. Now the next thing we need to do is we'll add our Spark dependencies into the POM file. So let's go to the POM file, add a tag which says dependencies. Here we'll add dependencies. So the first dependency we need is the Spark core. You can download it from Maven Central. Spark core. I'm using 2.3 for this application. And the another dependency that I'll need is the Spark SQL. So these are the two dependencies and libraries I need to run with the Spark APIs. Okay, that's good enough. Now let's add some build definitions. What sort of jar we want to create. As I'm sure you all would be aware of, to primarily do our Spark submits and run our Spark jobs, we create that uber fat jar. So for that we need to add the build definition into the pom.xml. So let's add a tag which says build, and we'll add two plugins in the build definition. One for the Scala Maven plugin, another one would be the Shade plugin to create the uber or the fat jar, right? So let's add these two plugins. The first plugin I'm gonna add is the Scala Maven plugin to do the Scala Maven code compilation. Let's add this, and you can add the plugins tag because I'm gonna add two plugin here. So, and the second plugin that we need to add is in the build definition, add one more thing, that is the source directory. So our source directory would be src main Scala. So let's type in src main Scala. Perfect. That's our source directory where the code would be picked up for compilation. And the second plugin that we need to add is the Maven Shade plugin to create the uber or the fat jar. That will also carry the information about our main class. So if you look, this is the Maven Shade plugin, right? And we're using a transformer so that we can have an uber jar with entry point as our main class. That will carry a main method that will be an entry point for our Spark application, right? We added a final name. This is the name of the artifact or the jar file that would be created. So these are the two plugins we need, right? So let's save it. Now we are good on the deployment descriptor POM files update. That's good enough. Let's try to add some main class. So let's select this one. Do a right click on src main Scala to select Scala objects, new Scala object. Let's create a new Scala object. This is the name with which we want to create a Scala object. Let's do finish. Okay, so we got a main entry class. Let's add a main method in it. Running a little slow. Just give me a moment. Yes. So let's add a main method. Right. And in this main method we'll write our logic, the application logic, right? Whatever we want to write as part of that Spark Scala application. And one more thing that will need to run this Spark application is the Spark session, right? So let's add one more class to create a Spark session. So let's add a new Scala object, right? So here we'll add another class which says demo Spark session, right? let's do a finish. And what we need to do is here, let's add a method which says that Spark session, and it should return me what? It should return me a Spark session. So that's a return type. Okay. So you said Spark session is this, and then write a logic. So what we need to return here is we need to return a Spark session, right? So we will use Spark session dot builder, right? We can give app name, it is demo training. We can set the master, we can set it to local. We are trying to get our stuff run on local machine. Dot get or create, so that we'll always have one instance of the session running, right? If there would be no session, it'll create a new one. That's more handy in a shared cluster, in a cluster kind of environment, right? If you already have a session running, active session, it'll get us the same. Otherwise, it'll create a new session. So it'll give me a Spark session, right? Spark session dot builder. Okay, now let's go back to our main class and let's get an instance of Spark session to start our application code. Demo Spark session dot Spark session will give me an instance of Spark session. I named it as Spark. And what now I wanted to do is let's create some simple data. Say take an example of employee and department. So let's create a data for an employee and a data for department, and let's do a quick join to find out that which employee belongs to which department, right? So what we need to do is let's create employee data. What we need to do is val emptf, and what can we do is can use a sequence. So let's take employee ID. Let's take employee ID is 10. Next is employee name, say John, and says employee's department ID is say 100. Fair enough. So we're adding a tuples with 3 attributes. So let's say next employee is 11 and its name is Garner, and department ID is say 200. Let's add one more record. So we'll have 3 records in our employee data. It's Heaven. It's a name as say Mikey, and let's say the department ID is 3. So then we can convert into I'm not getting an option to convert it into a data frame. Yes, so what we need to do is we need to import implicit, import spark dot implicit. It'll give us a default it'll give us the default encoders and the API. If I'll do like this, I'll get let's name the columns. Let's try some name. So for the first one we says is EMP ID. The second one is the EMP name, right? And the third one is the department ID. Perfect. So that has created an employee data frame, right? Let's create a department data, right? Say val dep df department data frame. You can use the same sequence method to get our data frames created. So let's say department has two attributes this time. One is department ID and obviously some department name. Right, says 100 is for IT. Let's add two more records. Next one is, say we have 200, say for accounts, and say 300, say for HR. Right, this same stuff. .2f. Add the column names. The first one is the department ID, second one is the department name. So perfect. So two data frames are created. Let's see if those if that stuff is running, right? And before we do that, let's also join them and find out like what is the employee, which employee belongs to which department. So let's do a quick join. Let's find out the resultant data. Let's say val resultant is equal to empdf dot join with df, and on which column you want to join? You want to join it on department ID. Fair enough, miss. And the columns you are interested in for now is you're interested in, say, employee name and the corresponding department name. Perfect. Yeah, so we have selected two columns. Let's run this program. Let's do a dot show. Let's do that. Let's see that. And now to run this stuff, we on the local environment on your local machine, what you simply need to do is just do a right click on this, run as Scala application. Simple. We can go to console, started executing this program. Right, there are a lot of logs are coming. These are all info logs. So if you see, that's our resultant. That's what we have showed, and it showed me that these employees belong to this department. Fair enough. So that program works on the local environment. Now this is a sample data that we have created. This data could be, you can read a CSV file from your local system, or you can also read your Parquet or CSV files from the lake. We can do that integration. Right. One quick thing, there are a lot of info logs that we see. Probably that'll not help us to look into the information that we are interested in. Let's add a quick, let's add a quick log4j file, j.xml in the resource folder, right? And we can add some stuff in here. Can add it so that we don't see all these unnecessary info logs for now, and you can change the appenders based on what is your need. So just add this stuff, and let's run this program once again. Right, if we look at the console now, so we're not getting all those info logs now. It will only show us what we have printed. We're trying to see the resultant data frame. Still running. That is red. Yes. So now I've got that resultant data frame. We can also do a quick show on the individual data that we have prepared. We can do that. Yeah, again do a right click. sort of compiled. Let's run this application again, and the console will not get all those unnecessary info logs that we were getting. And yes, so this is our employee data, right? This is our department data. Then we simply join the two data frames, and this is my resultant data frame with two columns, employee name and department name, right? So this is how you can do a setup of your Spark Scala application with Eclipse IDE, and I'll share the this particular program on my GitHub, and you can find the link in the description box. At the same time, in the next video we'll look how we can get it connected with the some kind of a data lake or Hadoop lake or Hadoop HDFS, and how we can deploy this particular application now onto the Spark cluster. That will look in the next and subsequent videos. Just want to show you one more thing, that on the local systems you can also check out the Spark API. Just that we'll have to apply a little trick because there is no history server on your local environment. So what we can do, a small trick, I can add just println which says finish, and I'll run my application in it. I'll just put a debug point here, and I'll run my application in a debug mode. I'll just, rather than doing run as Scala application, I'll do a debug as Scala application, and just select a launcher, the first one, Scala JVM launcher, doing OK. Let's run it into debug mode so that we can hold that Spark session to keep on running, and then we'll try to look into the local URI of the Spark, right? On the local system, the Spark UI you can access on localhost port 4040. Perfect. Here you see, right? This is the Spark UI which is created on your active Spark session on your local machine. If you say this is the program we are running, this is a job main entry, you can click on that, right? You can go here. So there's only one stage, obviously, right? There's a sample data, there's no shuffling as such. It's running on local single node, and that I can access a lot of the information, whatever you usually see in your on your Spark UI, right? How much time it is taken and stuff like that. You can also check the details in your environment. Shows you're running it on Jerry 8 and stuff like that, correct? So because if I just not put that debug point, this particular Spark application execution would happen and it will kill the Spark session. So I won't be able to say, for instance, if I let that application go through, right, and if I go to the Spark UI again, so probably it'll not be available now. And the simple reason is I do not have any history server configured on my local machine, right? So if you want to quickly peek into the Spark UI and see what kind of information you can harness from there, you can just put a debug point on the last line of your execution program, and then look into the current stats from the Spark UI. So guys, that's it in this particular video. I'll share the code on my GitHub, and you can find the link in the description box. And in the next video, we'll look how we can deploy this stuff now onto the Spark cluster. So guys, keep watching. Have a great day ahead. Keep learning. Bye bye.